So in this video, we're going to talk about using matrices to solve systems of linear equations via the Gauss-Jordan method. And I'm assuming if you're watching this that you've never heard of what a matrix is, or maybe you've never done this before. So I'm just going to build the whole thing up for you. So first of all, what is a matrix? So no, it has nothing to do with Keanu Reeves, I'm sorry. So a matrix in math, it really just stands for an array of numbers. So typically when you see a matrix, it's going to have square brackets like you see here, and then it's going to have a bunch of numbers in it. And the numbers can have as many columns or as rows as you want. So these are just a few different examples of matrices. They can get pretty big or they can be small, whatever. And the thing about matrices, you can take entire classes of mathematics dedicated to the study of matrices. So you usually don't know about them until a little bit later in your mathematical career, but they're actually pretty important and you can do some pretty amazing calculations with them. So in this video, we're just going to talk about some of the basics that you can use matrices for. So in one of my last videos, I talked about systems of equations, and you might remember solving systems, from algebra. So the thing is that every system can be set up as an augmented matrix. So what does that mean? Okay, so let's say that I have this system here. So it's really easy to set up the augmented matrix. Basically, what you're going to do is you just take the coefficients. So when I set this up, so I'm going to have 3, 4, 1, and -1. So notice those are all the coefficients over here. And then very often, something about an augmented matrix is usually we draw like either a line or a dotted line here to represent that, this is representing a system. And then you've got kind of what this is equal to. And so you can visualize here, this is really your X column, this is your Y column, and then this is your equal to answer column. So that is how you can set up an augmented matrix. And that's really the first thing that we want to get used to. And the way that we would describe the size, so we always do rows by columns. So the size of this matrix would be 2 by 3. And that is what's known as the dimension of the matrix, which is a pretty important thing to understand. So just to give you a little practice in this idea of working with dimension, so just what would be the dimension of this matrix here? So remember, we go row by column. So I've got 1, 2, 3 rows and 1, 2, 3, 4 columns. So this is a 3 by 4 matrix. Now, maybe you want to just pause for a second and think about this next one. What would the dimension of this one be? So the dimension of this one is a 4 by 2 matrix. So that is just one of the common things that come up with matrices, and knowing dimension, like I said, it has a lot of applications that we'll talk about as we start to explore more with matrices. So we just want to discuss that for now. And okay, so the thing with matrices, you kind of do some different types of mathematics with them. So with matrices, you do calculations within the matrix, and there are 3 possible row transformations that we can do when we're working with matrices. And this is it. This is all that you can do. So it's actually a pretty simple set of operations, thankfully. So the first thing that you're allowed to do to a matrix that will not change, what the value of the matrix is, you can interchange any 2 rows. And this makes sense if you think about it, because if you're thinking about a matrix represents a system, it doesn't matter which equation comes first. So you can interchange any 2 rows, and that is a perfectly acceptable row transformation. The second thing you can do to a matrix is you can multiply or divide any row by any non-zero number. So again, this operation is just like when we multiply an entire system by one number or divide it by one number so that we can use the elimination method. So this is kind of the equivalent operation when you're working with matrices. And then this last one kind of it kind of leans on like what we're doing with the elimination method in systems. So in matrices, what you're allowed to do is you can replace any row by the sum of that row plus a multiple of the elements of another row. Okay, so I know that sounds like a mouthful, and it's easiest really to actually explain what this means by getting our hands dirty with an example. So I'll just state this for now, and I'll show you how to use it in a moment. So we're going to use all of these operations. Okay, so these operations we're going to use with the goal of solving a system using matrices. So we know we can solve systems with elimination method and substitution method, and now we're going to talk about how to do that with matrices. And the way that we do this is with a method known as the Gauss-Jordan method. And so that's what we're going to break down in this lesson. So it seems a little complicated at first, but it's a kind of an algorithm. So once you understand what the algorithm, it's like the same set of steps every single time. Okay, so I will tell you the goal. The ideal form of a matrix that's like in its solution form is what's known as diagonal form or reduced row echelon form. Say that 10 times fast. So let me show you what this means. Diagonal form means that we do a bunch of manipulations on the matrix until we get it to look like this. Ones down the diagonal and zeros everywhere else with some numbers over here. So here's a small version of that, and then here's a larger version of that. So I just want you to understand what our goal is before I start jumping into it. My goal is to transform a matrix from whatever form it's in into something that looks like this. And it's a really prescribed set of operations to get to that. I'll just show you a couple more examples of this. Okay, so look at this matrix here. So sometimes when you're working with matrices, as you're trying to get your ones down the diagonal, you actually kind of run out of room to keep going with ones. So this is a matrix that has more columns than rows. So we can't achieve that perfect form, but you go as far as you can. So you get as many ones starting in the top left, and then you just keep going as far as you can. And then if there's stuff left over on the side, we'll talk about how to deal with that. But again, this would still be in that diagonal form. And something that can happen is, and we'll talk about this too, you can work through some of these matrices and you can run into something where you get your one and then you might end up with a row of zeros or something weird happens. This has a different interpretation, and I'm going to save this for another video, but I just wanted to point out here is a way that when you're working on this method, this could also happen, okay? So we get that general form that we're looking for. I always like to refer kind of to this matrix, so just the ones down the diagonal, zeros everywhere else. That's the big thing that you want to think about. Okay, so in using this method, you always want to work from left to right in your matrix. So the idea is that you want to get your first one and then use that one to get the zeros in the rest of the column, move over to the right, and then get your next one. So I want to point this out one more time because I'm trying to help you build a little bit of intuition before I just jump into this, because you're going to be like, wait, why are you doing this? So the goal here is you first get, so I'll just point these out, these ones. You always first do whatever you have to do to easily get this one here. And then after you get that one, you focus down the rest of the column to use that one to get these zeros. So it's a very prescribed process. Get the first one, get the other zeros. Then when you've gotten all your zeros, you move on to the next column and you work on getting the next one down the diagonal, okay? So this would be the next thing that we would focus on, is how to get this. And after we get that one, then we're going to use that one to get the other zeros in the column. So I'm just kind of pointing out the pattern so that you can watch how I do this as we start going through different examples, okay? So let's jump into an example now where I can actually use it. I've kind of shown you some of the ideas. Let's execute. Okay, so I want to solve this system using the Gauss-Jordan method. All right, so what I'm going to do is first I'm going to set up the augmented matrix. And I would actually recommend that you pause here and try to do that yourself and then hit play when you're ready. Okay, so I have -2, 4, negative 4, 1, negative 1, and 4. Okay, so there we go. All right, so the first thing that I want to do is, remember, I want to get my 1 first. So where do I want that 1 to be? This spot here, I want this to turn into a 1, okay? That is the only thing I am focused on right now. I don't care about anything else except getting that 1. So there are 3 ways that we can go about doing that. I'll remind you. You can interchange any 2 rows. You can multiply or divide any row by any non-zero number. And then we have this third one. This third one is not going to help us right now. So I will tell you that to get that 1, you're either going to interchange 2 rows or you're going to multiply or divide any row by a non-zero number. And in this particular example, we can actually do either. So I like this because this shows you some options. So one thing that I could have done is, and what you're going to want to do as you draw this out, by the way, you want to draw out your matrix, and then to the side of it, you want to note what operations you're doing. So what I'm going to do is I'm going to draw a little arrow here, and I'm just going to note, I'm actually going to write R1 and R2, that stands for row 1 and row 2. You want to be really intentional about explaining what you're doing, because when you go back to check your work, it's going to help you a lot. So I'm going to draw an arrow showing that I'm flip-flopping them and just noting which rows I'm doing. This is just a good habit to get into. Okay, now this is one way that you could do this, all right? So I could flip-flop the rows. That's totally fine. Very often this does not work though, and so the other option that you could do is, so let me actually, I'll do this other option in pink for a moment. So we will, just to show you, let's see, let's do it in green. So the other thing that I could have done is I could have divided, let's see, I could have taken this row and divided, so taken R1 and divided it by -2. So why divide it by -2? Well, if I did that, that would turn this number here into a 1. So just to show you what that would look like, that would be 1, -2, and 2, and then 1, -1, and 4. So you could have done either one of these methods. So I'm just showing you that sometimes you have options with how to get the very first one. It doesn't usually work out like that, but in this case, we have options. Okay, so I just wanted to show you that, I wanted to mention that. So let me get rid of all that. And I want to just push forward with the method that I was using. So R1, R2. Okay, so now that I have my 1, so remember what I told you. You want to get your 1 and then get your zeros. So now I'm going to use this 1 to work on making this thing right here into a 0. Okay, and that's where this last kind of mouthful of a row transformation comes in. So you can replace any row by the sum of that row plus a multiple of the elements of another row. So what that means is I'm going to take row 2. So let's see, I'll write it over here. So I'm going to start with row 2. And then what I'm going to do is I'm going to add row 1 to it, but I want to add a specific multiple. So I'm going to use this 1 so that I can get a 0. So what do I have to multiply the 1 by so that when I add it to this, I get a 0? I need to multiply the 1 by a 2. So what I'm going to do is I'm going to go like this. I'm going to note that. I'm going to take row 2, and then I'm going to multiply this whole row by +2 and add it to row 2. You see what I'm saying? So let's think about what that actually means. I want to draw this out for you. So normally you wouldn't maybe show all this detail. Sometimes you can just kind of do it by doing it in your head, but let's write out all the detail. So in doing this, this is a manipulation to row 2. So I can just rewrite row 1. Nothing should happen to row 1. Once you get that 1, this should not be manipulated again, okay? So what's happening in the bottom, though, is that I have -2 plus, let's see, actually I'm going to give myself way more room than this. So I'm going to have -2 plus 2 times 1, okay? So I took that and then 2 times 1. So now let's move to the next column. So I've got 4 plus 2 times -1. That's what's happening here. So I'm taking this -1 and multiplying it by 2. So you see that's what this is getting at. And then for that last part. So I've got -4 plus 2 times 4. So what you're doing is you're taking each number here, you're multiplying it by that 2, and then you're adding it to the bottom row as you see here. And so this is what we're going to work out. So let me clear a little space. And so now let's just sort out the calculation. So nothing's happening to the top row. We did nothing to that. The bottom row now becomes 0, right? Because -2 plus 2 is 0. This was the goal. So that's good. That's what we wanted. 4 plus 2 times -1, that's really going to be 4 plus -2. So this is going to be 2. And then -4 plus 2 times 4. So that's -4 plus 8. So this is just going to become 4. All right. So now look at what we have. The first column is done. And now I want to move on to the next column over. So remember what I said, when you move to the next column, you are focused on getting a 1. And now the only operation you can really use to do that is the division operation, or the multiplication or division operation. So what I'm going to do is I have to now transform this into a 1. So what do I have to do to the 2 to turn it into a 1? I have to divide that row by 2. So I'm going to take row 2 and I'm going to divide it by 2. So I want to just note that to the side. Nothing is happening to row 1, so I'm just going to restate it. And then row 2 becomes 1 and 2. Okay? All right, so next, what's the next thing that I want to do? I got my 1. So next, I want to focus on getting zeros in the rest of the column. So this needs to turn into a 0. And so what do I need to add to this to turn this into a 0? I need to add 1 to this. And thankfully, that's just this row down here. So what I'm going to do is I'm going to take row 1 and I'm going to add just row 2 to it. So let me write out the operations as to what's happening here. This is 1 plus 0, -1 plus 1, and 4 plus 2. So it is row 1 that is changing, and I'm adding row 2 to it. Nothing is happening to row 2. Okay? So that's what it's going on in the background. So let me clear some space. And then we can just finish the math. So this will turn into 1, 0, 6, and 0, 1, 2. And look, now we have this in the desired form. And I want to point out something about just how this works. So by getting a 0 here, then when I start to add like other rows, like when I start working on this column, since there are all zeros in this column, nothing's going to happen to this 1 here. That's the beauty of starting from the left and working your way over. It will just maintain the column. So that's why we have this extremely prescriptive way that we do this. Okay, so now what do I do with this? Well, this is, remember, this is the X column, this is the Y column, and this is the equals column. So I have 1x here equals 6, and y equals 2. So the matrix spits out the formula. Boom, no problem. So that's how we use matrices for this. So I want to do another one, very similar example. I want to encourage you to try this one entirely on your own. So set up the augmented matrix and do your best to try to do the whole example. So refer to the notes that we just talked about and really try to push yourself to do this on your own. You will understand this so much better if you try it on your own. If you make a mistake, that's totally fine. Just hit play when you're ready. Okay, so first I've got to set up the augmented matrix. And in this case, the easiest way to get that 1 would be to flip these 2 rows. So this is going to be 1, -1, and 13, 3, 4, and 4. Okay, so next I have the 1, so then I want to get my zeros in the rest of the column. So this says 3, so what I need to do is I need to add -3 to it. So I'm going to take row 2 and I'm going to take row 1 and multiply that by -3. So let's write out all the work that goes into that. So the top row, nothing is happening. Let's see, top row, nothing is happening. But in the bottom row, I'm going to have the bottom row plus -3 times each element in the top row. So if I continue this pattern, so I have 4 plus -3 times -1, and then I have 13, and then 4 plus -3 times 13. So there's all the work going into this. So let's clear some space. And I've got everything kind of crammed in there, but now I can go ahead and just write out what happens with these operations. So here I get a 0. Let's see, nothing happens to the top row, so I'll just note that. So let's see, this becomes 4 plus 3, so this is 7. And then 4 plus -3 times 13, so this is going to come out to -35. Okay, so now I say, I got this column done, so I move over to the left, and now I want to move down the diagonal, so I want this to turn into a 1. So the only way that this can turn into a 1 is if I divide row 2 by 7. So if I divide it by 7, then I get, so the top row does not change, and the bottom row becomes 0, 1, and -5. And so now to finish this, all I have to do is I have my 1 here. So now what do I want? I want this to turn into a 0. And so I need to add, what do I need to add to -1 to turn it into a 0? I just need to add a 1, which I have here. So what I'm going to do is I'm going to take, let's see, actually I'll write it in this color. I'm going to take row 1 and I'm going to add row 2 to it. And just to be clear, I want to write out what is the math that's actually happening in this row so that you can see I'm literally taking that second row and I'm adding it. So let me clear a little space. And so now I can finish this. So this is 1, 0, 8, and 0, 1, -5. So this is my X column, my Y column, and my equals to column. So this means that my X equals 8 and my Y equals -5. So those are the two ways you could represent that answer. So that was a lot of information that I threw at you. Those are the basics. In the next video, I'm going to show you how to do this process with a larger matrix. So I'm going to cut the video off here and I will just catch you guys in the next video. So I'll see you in a moment.